Good day everyone. In today's video, we're going to be talking about use substitution for integration. I believe you have come across chain rule before, and you know in solving chain rule, we make the internal function, we substitute u for the internal function, and then we integrate it. Okay, it's just the reverse for the chain rule. In integration, it's just the reverse. Before we start, you must know that use substitution is not usually used randomly, but it's used inside the function. Okay, for example, when you have x squared plus 1 raised to the power of 5, if you want to substitute you are going to say u is x squared plus 1. Is the internal function, not the function itself. Alright, if that's clear, let's just take some examples. If you are asked to integrate 2, let's say s squared ds, this we call it direct integration. We already discussed the methods in the class, and I told you all the methods we can use. So if you want to integrate this is just the direct method, the direct integration. You use the power rule. We say that s raised to the power of n. If you want to integrate this, is s raised to the power of n plus 1 all over n plus 1 plus your constant. Right? So the same is true for this one. If you want to integrate this, it becomes s2 plus 1 all over 2. So this is going to be equal s raised to the power of 3 all over 3 plus c. That is 1/3 of s cubed. That will be the answer. So this is what we call direct integration. However, there are some integrations that you cannot integrate directly. You have to use what we call use substitution. And from the onset of the video, I said use substitution is used when you have a function inside another function inside an integration, symbol. For example, when we have s is equal to 2x s squared plus 1 raised to the power of 3 ds. We cannot use direct substitution here, but what we can use is use substitution, and this becomes we make this u, because with the idea that when we integrate this, we're going to get 2s. So these 2s, they will cancel out. So you first have to picture it and know that yes, this method will work. So we now have integral of 2x dot u cube ds, right? Where u is x squared plus 1. So that the u is equal to 2s ds. When you differentiate with respect to ds here, the u ds, you're going to get 2s. Are we good? Good. So ds becomes what? Du over 2x. I believe you understand. Good. So we substitute du ds for ds here. We now have integral of 2x dot u cube. Instead of ds, we're going to say du all over 2x. You can see clearly that 2x can go. So what we are now left with is integral of u cube du. We can now use the power rule here. So this becomes u to the power of 3 plus 1 all over 3 plus 1 plus c. So this becomes u to the power of 4 over 4 plus c. And of course, the final answer becomes we'll substitute our s squared plus 1 for u, because the initial question was not given in variable u, but in variable x. So we now have x squared plus 1 raised to the power of 4 all over 4 plus c. So this will be the final answer for this question. Alright, so we have integral of 3x squared, let's say s cubed plus 2 raised to the power of 5 ds. So go ahead and pause the video and try this one. Alright, just like we did the other one, it's the same thing. It's the same thing we're going to do here. So we're going to make this inner function u. We're going to substitute u for the inner function. So we have integral of 3x squared plus multiplied by u raised to the power of 5 dx, where u is equal to x cubed plus 2. So that the u is equal to 3x squared plus 0. If you integrate a constant, give us 0 dx. Differentiate a constant, give 0 rather. So ds is now equal to du all over 3x squared. So we now have integral of 3x squared multiplied by u to the 5. Alright, instead of ds, we're going to say du over 3x squared. So this will go with this. I'm now having integral of u to the 5 du. And this will now give us integral, this will give us the final answer for this using the power rule is going to be u to the power of 5 plus 1 all over 5 plus 1. And this will give us u to the power of 6 all over 6. And substituting this so that we can change the variable back to s, we have x cubed plus 2 all over 6 to the power of 6 plus your constant, of course. Alright, if you don't understand, feel free to rewind the video and you'll get it. Alright, there is another question that we must do. You can also try this. We have s raised to the power of x plus 2 ds. How do you think we're going to integrate this? Because clearly, if we differentiate this, we're going to get 1. So we will not be able to cancel out this. So what do you think we're going to do? Alright, we're still going to use substitution because we have a function inside another function. Alright, so we are going to say that x root u dx, where u is equal to x plus 2. We're not going to differentiate this because when we do that, we're not going to be able to cancel out this. So what we can do is to make s subject, which x is equal to u minus 2. Alright, so let's point out this. This is going to be our most important equation. So the next thing we can do is to differentiate ds with respect to du. Alright, so that ds du is equal to 1. It means ds means dx is equal to du when we cross multiply. So we'll come back to our integral and we substitute u minus 2 for x and dx for du. So when we do that, we're left with u minus 2 for x integral of u dot ds becomes what? Du. Now we have an homogeneous variable u, and throughout is u. So we are going to continue. If we do the math correctly, we are going to have this u raised to the power of half is the same thing as root u. So we have the u. Alright, so we're going to distribute this. Alright, so we now have integral of u multiplied by u cubed, u raised to the power of 2. We're going to get 3 over 2 minus 2u raised to the power of 1 all over 2 du. Here we can use the power rule. Alright, so from the power rule, the final answer becomes u to the power of 3 over 2 plus 1 all over 3 over 2 plus 1 minus 2u to the power of 1 over 2 plus 1 all over 1 over 2 plus 1 plus your constant c. So if you do the math correctly, you are going to get this. So at the end of the day, you are going to get this as your final answer. You are going to get this as your final answer. 2 over 5 s plus 2 raised to the power 5 over 2 minus 4 over 3 s plus 2 raised to the power 3 over 2 plus your constant. Now, I want you to try this for me. Cos 5x ds. This is going to be the last question in this video. So, what do you think will be the integral? When we talk about trigonometric questions, you should know that when we have if we want to differentiate sin x ds, we're going to get cos s. Now, if we want to integrate cos s, it's true that it's just reasonable that we get sin s. So with that sorted out, we can still use our u substitution here. So this becomes integral of cos u ds, where u is equal to 5x. When we integrate this, when we differentiate this, we will find out that du is equal to 5 dx. So that my ds is equal to du over 5. Alright, so with that at the back of our mind, we can say this becomes cos u dot, instead of ds, we are going to use du over 5. So we're going to take 1 over 5 to the back side of the integral because it's a constant and it's multiplying, so we're just going to take it to the back. So we have 1 over 5 integral of cos u du. Now we have an homogeneous variable here, so when we integrate cos s ds sin s, so it's just choosing that cos u du will be sin u. So we have 1 over 5 sin u plus c. So taking it back to the initial variable, we have that the final answer is 1 over 5 dot sin 5x plus c. Alright, so this is the final answer. If this video is very helpful to you, make sure you subscribe to the YouTube channel, and of course I'll see you in the next video. Bye bye.